there is a lack of standardized toolkits in the market. And the standard kit that is Gazebo that currently is used in the market, it simply is not good enough. It is a good tool for education, but it is not scalable for industry level applications, owing to the huge reality gap that is between simulation and the actual development. And anyway, simulation is not enough for robotics development. We need to have some sort of digital twin solution for the robotics. Yeah.
Coming to our solutions, as Madhu just told you, there's a reality gap in robotics. What does reality gap mean? When you develop a simulation, you develop a robot, and you deploy it in the environment, and what you observe is it's behaving differently. So, Gazebo is the only standard tool that ROS developers use. I've been into ROS for the past 4 years. I've been working in marine robotics for the past 1.5 years. So I know that the behavior that we expect the robot to do is not what it actually does, and it does something different. How Stingray comes into the play is we are trying to standardize the process of a robot development life cycle through our first of all digital twin and secondly simulation solution. We are developing a platform that can actually help you bridge the reality gap to as close as possible. So these are some screenshots from our current prototype that we are developing. As you can see, this is our marine robotics simulator. Since both of us have a good background in marine robotics, we started with it. Also, there was a lack of tools. I interacted with about 30 plus academicians in marine robotics specifically at MRS in Goa. And what I learned was they do not have any concrete solutions to simulate marine robots. UUV simulator was the only concrete product and it stopped development after 2017 and that also used the Gazebo sim. So we tried simulating multiple. We have simulated AUVs, we have simulated some ROVs, we have tried simulating ROVs in collaboration as well. But what we are essentially developing is a single where you can, simulate, get computer vision data. So if I let's say develop a robot and I need to deploy it underwater to get some coral reef data, the cost of deploying a robot, taking to the perfect site, getting a perfect visibility, taking it down and reflecting the data, and after that labeling is too high. So what we are trying to do is having a complete computer vision toolkit where you can generate three-level data sets, having accurate physics-based models, because the simulation needs to match the reality. That's why we are focusing on hydrodynamics accuracy. What is hydrodynamics? Is my audio? Is it okay now? Okay. So hydrodynamics it basically includes. Is it? Right. Okay. So we are trying to simulate the hydrodynamics accurately, the damping effects, the Coriolis effects, the hydrodynamics, and all the other applications. We're trying to optimize multi-agent collaboration as well as collaboration in robotics, and also providing out-of-the-box support for RDUSER, MUSE-ITP, ROS, or any other robots that can be used. Starting with marine robotics, we are trying to integrate and penetrate into all these two industries, terrestrial and aerial robots. Coming to the robot development life cycle, let's say a company decides to develop a robotic arm or a marine robotics in case. On the left, you can see how the robot development life cycle goes about. You design a CAD product and then you do the mathematical system modeling of that, and then you move to the controller and algorithm design, then you simulate the robot in Gazebo, and then you deploy it. What you then realize is it's not performing accordingly, and then you repeat this cycle till either you optimize your controllers or optimize your system model to match the reality. How we are approaching this is we are trying to model the sensor and actuators directly in the simulator with accurate physics, and so that you can focus on developing the controllers and algorithms rather than perfecting the model. So we can then simulate with that toolkit, and in less than 100 iterations, we can have a perfect deployment. When you have a perfect visualization, it actually becomes a digital twin. Now, when you have a digital twin that behaves exactly like a robot is behaving in the real life, you can do predictive maintenance. You can actually do all the observations, and you can understand how you can optimize the product basically. Coming to the architecture, the current architecture uses bullet physics as its back. We can have multiple rendering engines. As of now, we are targeting Unity and Unreal Engine to render our visions and, of course, generate data sets. We are using ROS for sensor simulation and cross control as well. Set size now. These can be replaced accordingly, but because we are completely focused on the development life cycle, not on the single controller stack. So we have a PyQt with customizable environments. Right now we come with 4 environments, and we have the direct output support for URDS and environment SDS.
Coming to the market side, we are addressing a near $65 billion robotics market. We have identified high potential use cases, mainly AUVs and ROVs for our underwater simulation, industrial manipulators, warehouse robotics, and UAVs. the digital twin adoption in the robotics industry is growing fast. The digital twin market is growing at a rate of 39.8% annually. Yeah. And coming to a revenue model now, we have three sources of revenue. The first, we are expecting most of our revenue to come from a SaaS-based product, where we offer our solutions to a diverse range of industries, including robotics research lab, defense organizations, healthcare organizations. Also, we will be offering a custom white label solutions to other robotics companies. Suppose they have a preset environment and a preset vehicle that they need, and they are offering service simulation to their client. We can do a white label solution for them. Another is our educational tool, which is not a very big chunk in our revenue, but it is important for adoption of our tool in the industry. Yeah. So we have identified these key services that we will be providing to these industries. As you can see, we are actually adding a lot of value to all robotics research lab, defense organizations, healthcare, manufacturing, all the organizations. Yeah, this is what our roadmap looks like. We are currently developing a product, and we are doing a collaboration with NIO. We are integrating their vehicles in our simulation system. Within 3 months, we would have an MVP, and within a year, we are planning to make a market-ready product. And from next month, we will be looking at a fundraising round. Yeah. Coming on to who we are, I am Madhu Juneja. I have been working with Marine Robotics in the past 2 years now. First at NIO and then at IIT Bombay. I worked for the project for the Indian Navy, and my co-founder Jajapan Singh, he's also worked at NIO in the past. He specializes in computer vision and marine robotics. So our vision is to become to the robotics industry, but Figma has become to the design industry. I now open the floor for questions.
Again, this is a very, very complex problem. You are getting into, you are bypassing the system modeling with the sensors, simulation of the sensors, so that you can bypass the system modeling aspect.
No, sir, we're not bypassing the system modeling. We are doing for the customers. We are doing it ourselves for the customers. We have done system modeling for AUVs and ROVs. What we are trying to do is, instead of you going and modeling every AU and ROV from scratch, the essential physics remains the same. So we model it for you. You just tell us where sensor placed at, where is your relay located, where is your USB located, where are your actuators located, and just put it in the config file. The robot is ready for you, which will be closer to similarity because we validated with our real robots.
The interaction of your robot with the underwater environment, right?
Yes, sir.
How do you model that?
So yes, sir. So as I think the equation is shown in one of the further slides, it's called the Fawcett hydrodynamics equation. This equation basically defines how a robot or how a marine vessel actually interacts with the environment. We have done this modeling in MATLAB. First of all, we validated with real robots. I learned all of this at my work at NIO, and then we did it on in Unity engine, and also we are trying to validate it with the current robot.
See, the timelines that you have put, to me, they look very, very aggressive, having seen,
yes, sir.
Being there around the block many times.
Yes,
so
sir.
I think the timelines are too aggressive. You are attempting a problem which is at probably TRL level 2, 3 kind of a thing when the sensor modeling, all these things are concerned. So you need to put so much of buffer in your planning.
So we do believe in iterating over the industry. So I think if we have an industry-ready product as soon as possible, we can improve it on the go.
This is too technical for me, but I'll just ask other questions.
Yes, sir.
What made you to start this company?
So I've been fascinated by robotics since my class 8. I've been working on parallax robots, and then I started working on UAVs in my second year. That's where I met Madhu. And being a scuba diver, I've been fascinated by the underwater world as well. So robots observing the underwater world was one of my fascinations, and the gap I observed while working in underwater robotics, the lack of accurate simulation environments, and robotics in general, on the lack of, first of all, digital twins, and secondly, development pipelines. You should have a standardized process. Just like Figma does for design process, you have a UX, then you do the UI. Figma puts this all together, from the user case studies to developing the wireframe, then developing the prototype. That's what we are trying to build for the robotics community, a single standardized pipeline, a single standardized tool, where actually you can depend on to first of all model your system, develop your simulator, and then go to the digital twins part of that.
So how long you guys been like met together and working on this thing?
We met while we were in college. I was in my third year of college and he was in second year. That was back in 2022. So we have been working with robotics for the past 2 years. I have been working for the past 2 years and he's working I think more than
One.
Yeah. Not professionally, but yeah. So we've been working on this product for the past 3 months.
So what is the plan for you to go forward? You have a POC because you mentioned that you already did some work for someone.
Yes, sir.
So where are they? Are they acceptable in the industry? Are they just like still work in progress?
Yes, sir. So, NIO is one of the topmost marine robotics developers in the country right now. So, what we are trying to do is they have already very good underwater robots available to them. We are developing the simulators from them. And we are trying to validate that how do they compare to the reality that they have right now. We are still in the validation stage of how we can improve the exact system model or what other things we can do, such as ocean currents, how we can model it properly. Because ocean currents are essentially complex structures. So you can't just go like a vector se define kar do. So we are trying to simulate how close to reality we can come right now.
Okay. Thank you.
Yes, sir.
Thank you, team, for your presentation. I wanted to ask, why is the name Stingray? Because the robot looks like a stingray.
The robot does not look like a stingray, but stingray is a very interesting animal, so it gracefully passes through the ocean. It has two flapping wings basically, not like a fish, and it goes as fast as 30 miles an hour. So stingray has been a very great animal and it has all the properties. It's offensive, it's defensive, it can take cover, it can hide, it can do both. So stingray is, that's why we chose the name, Stingray Robotics. And since we are coming from a marine robotics background initially, so that's how we approach it.
Interesting problem statement. The first question is, do you have any IPR associated with it?
We are currently, our entire focus is on the product development. We have not, we are exploring the IPR route, but still we don't have anything concrete per se.
So what are the possible challenges that you have faced or you're going to face in the product development?
So one of, in the product development or the adoption, you're asking?
Development.
Okay, the product development. So one of the challenges is that how do we, so first of all the system modeling is again one of the challenges, and secondly there are a wide range of sensors available. If I even talk about a basic IMU, MQ6050A, MQ9250A, then we go higher, we get Spark 1, expensive unspected nav. All of them are supposed to do the same things, give us 6 data points. But yet, when we put it on the test, it gives different data for every sensor. The noise in the data, the robustness of the data changes. So how do we model that? Because the same robot could be using different sensors. So how do we model that into our product? Is one of the challenges. How do we model a lot of sensors? There are 50 bands for it selling a DVL or selling a USBL. So a robot might be using one of those. So that's why we are trying to provide. You just select the sensor, you have it on the robot. So, but that's what we are trying to model, and that's one of the major challenges that we're facing right now.
So how do you differentiate yourself among competitors?
So I have identified only one competitor as of now, which is called Duality.ai. Duality is more focused on the rendering pipeline. It's actually more of a plugin for Unreal Engine than a complete product. We are more of a complete lifecycle product of the entire robot, from the design journey to the mathematical modeling, and after that to the digital twin as well. So that's how we differentiate ourselves. And second of all, nobody of them is doing underwater robotics. We are specifically initially starting at underwater because underwater is one of the most tougher domains in robotics. You don't have any GPS, you don't have a lot of vision over there. Your water activation, your backscatter also obstructs the camera view. So we're starting with underwater because once you capture the toughest domains, it's easier to go for the rest.
So currently you are only 2 members in the team, right?
We are 4 of us right now. Thank you, sir.
Well, thank you, Madhu. Now, moving on to the next one, it would be Mr. Narasimha Murthy, representing Complex.